Welcome to ACD NMR Manager Structure Verification. This movie will outline how to check the correspondence between the experimental spectrum and a structure. Assign a complete structure to a spectrum with the click of a button. View the assignment and residual graphs to determine assignment accuracy and determine whether the spectrum represents a mixture of compounds. This is the NMR spectrum of catechin with multiplets created by the J-coupler 2 tool. Notice that all extraneous signals such as solvent and HDO are masked by dark regions. The auto-assignment algorithm is a key part of verification. There are variable weight factors to take into account: chemical shifts, multiplicity, and quantitative information. It is also possible to set prediction tolerance and looseness, as well as integration accuracy parameters. Multiplicity can be optimized using a threshold value for the coupling constants. Spectrum calculation options similar to that used in H and CNMR predictors are also available. The spectrum shape options govern the curve appearance in the spectrum, but do not affect the verification. To ensure that the changes in the prediction options are applied during the current session, one must select the Create Predicted Spectrum checkbox in the Auto Assignment Options dialog box. A high match factor value, also indicated by the green circle, confirms the structure. A high structure purity value points to the absence of major impurities. Sometimes it is useful to distinguish assigned and non-assigned atoms in a structure. One can set a color for assigned atoms in the Preferences dialog box. The table of assignments now includes experimental and calculated chemical shifts and their differences. As well, the table makes it easy to control assignments. The same information is also available by means of graphs of assignment and residuals. The latter graphs show chemical shifts differences plotted against experimental values. Confidence limits defined by shift looseness help to find dropout values. Exchangeable protons can be ignored during verification, but be careful if their signals do appear in the spectrum. Note that the match factor hasn't changed, while the structure purity has decreased significantly. The experimental spectrum and the spectrum calculated during the verification process are automatically synchronized. Strong extraneous signals in the experimental spectrum can be offset by synchronizing only the horizontal axis. Now it is possible to check the assignment concurrently in all spectra displayed. ACD NMR verification can also be applied to mixture analysis. Let's verify if this is a single pure component. Although the match factor is high, the structure purity value suggests the presence of an admixture. Close inspection reveals that one singlet at 3.4 ppm is not assigned. This signal is similar to that of a methoxy group possibly coming from an isomeric structure. This hypothesis can be checked on the same spectrum with two isomers shown explicitly. Now, structure purity is close to 100%, and each singlet is assigned to methoxy groups and their respective isomers. Finally, NMR verification is applied to very complex, multi-component mixtures such as human urine. The The spectrum was recorded with a water suppression technique and contains a lot of signals. We will check if hippuric acid is present in the sample. The verification result does confirm the presence of this compound, although at a low concentration. Inspection of the aromatic region reveals that the assignment is in complete agreement with typical multiplet patterns. With ACD NMR Manager, you can easily process, manage, and analyze your NMR data, build your own database as you analyze each spectrum, and prepare high-quality reports with spectra, structures, annotations, and tables.